Beneath every forest, behind every fallen leaf, there exists a hidden kingdom, a realm older than trees, quieter than wind, and more mysterious than most of us can imagine. It lives in silence, weaving itself through soil and shadow. We call it the world of mushrooms. They are not quite plants, not quite animals, but something in between, a lineage that branched away long before the first forest rose. They breathe oxygen and exhale carbon dioxide, just as we do. They move without walking, eat without mouths, and grow without sunlight. They belong to no single world, and yet they sustain them all. When you look at a mushroom, you are only seeing its brief appearance above ground, a fleeting moment in a story that runs deep. Beneath your feet stretches a living web that may be older than the forest itself. Each thread hums quietly, sharing signals and nutrients through soil the way thoughts move through a dreaming mind. Mushrooms are the dreamers of the earth, healers, recyclers, and sometimes destroyers. They turn death into life, wood into soil, and silence into renewal. In their patient rhythm, the planet breathes. Some live for days, others for centuries. Some glow faintly in the dark as though lit from within, tiny lanterns among the moss. Others remain unseen, forming vast underground bodies that span mountains. To understand mushrooms is to glimpse one of nature's oldest systems of cooperation, a hidden architecture that connects roots, stones, and the memories of rain. Long before we built cities or circuits, the forest already had its own network. It whispered in spores, in threads, in silence. Mushrooms also remind us how life blurs boundaries. Genetically, they are closer to us than to plants. At the molecular level, their cells resemble ours. Their walls are built from chitin, the same resilient substance that forms the shells of insects and crustaceans. They breathe the same air, drawing in oxygen and releasing carbon dioxide, exchanging gases with the world just as our lungs do. It means that when a forest breathes, in some quiet sense, it breathes with us. This kinship is easy to overlook. We often imagine the green world as separate from our own, a stage upon which we merely walk. But in truth, the fungal realm is a mirror, a reminder that the difference between human and mushroom is a matter of form, not of essence. We are both storytellers made of carbon, both dependent on air, water, and decay. Somewhere deep in our shared ancestry, we diverged, yet the breath remains the same. And in the soft darkness of the forest, some mushrooms still keep a secret light. If you walk through damp woods at night, you might notice it a greenish shimmer rising from rotting logs or hidden under leaves. It is not a trick of the eye, but life-transforming chemistry into radiance. More than 70 species of fungi are known to glow in the dark. Their light, called bioluminescence, is born from a delicate reaction involving an enzyme named luciferase, the same process that gives fireflies their spark. To witness it is to see magic turned into biology. Imagine a forest floor scattered with tiny stars, the air still and cool, every glowing cap a reminder that beauty often comes from decay. Scientists believe this glow may serve a purpose, perhaps to lure insects that help carry spores farther into the night, or perhaps to warn hungry animals away. Whatever the reason, it feels like a quiet defiance of darkness. A message that even as wood breaks down and time dissolves structure, light still finds a way to return. Life continues to shine through the fading. But the greatest part of the mushroom story lies unseen. Beneath the surface, the mycelium. This is the true body of the fungus, a vast, invisible network of microscopic threads that weave through soil, roots, and stone. Each filament is delicate as silk, yet together they form something astonishingly strong. Through this underground web, water and nutrients flow from one tree to another. Dead matter is broken down, returned to the cycle, and fed back into life. The forest depends on it, though it never speaks its gratitude. If you could peel back the ground and see what lies beneath, you would find a living net stretching for kilometers, wrapping around roots like veins around a heart. The mycelium recycles everything it touches, turning fallen leaves into nourishment and decay into foundation. It is the quiet bloodstream of the earth, pulsing slowly, eternally. Some scientists call this hidden world the Earth's nervous system. And it is not a poetic exaggeration. Mycelial threads transmit electrical impulses, respond to changes, and even distribute resources intelligently, a kind of awareness woven from chemistry and time. It binds ecosystems into one breathing organism, where every tree, flower, and blade of grass is part of a shared conversation. When you stand in a forest and feel that deep stillness, you are standing above a mind, ancient, collective, and alive. Mushrooms are its messengers, the brief visible thoughts of a system too large to see. They rise through soil for a moment, release their spores, and vanish again, like a pulse beneath the skin of the world. This is the hidden kingdom, the one that lives beneath our feet and within our breath. It is older than forests, wiser than time, and endlessly patient. And tonight, as we drift through its stories, perhaps we will come to understand that the line between human and mushroom, between soil and sky, has never really been a line at all, only a thread, glowing softly in the dark. Far across the blue mountains of Oregon, beneath a quiet forest of pines and streams, there lives something vast, a single organism that stretches for nearly 4 square miles beneath the soil. To anyone walking above, the ground looks ordinary. Moss, needles, roots, and rocks. Yet every tree trunk and fallen log there rests atop one continuous being, an ancient fungal network known as Armillaria ostoii, or the honey fungus. It is, as far as we know, the largest living creature on Earth. Each mushroom that rises from the forest floor is only a small expression of this hidden giant, the brief fruiting body of an organism that has lived for thousands of years. Its mycelium threads extend endlessly beneath the surface, weaving together the forest into one slow, breathing whole. If you could trace its boundaries, you would walk through valleys and meadows, crossing miles of terrain, and still remain within the same organism. It outweighs whales, outlives civilizations, and yet moves with the patience of stone. Scientists first discovered its true extent only decades ago, realizing that what they thought were many mushrooms were, in fact, one continuous network. What looks like a forest of individuals is, in truth, a single being. To stand within it is to stand inside a living cathedral, its pillars made of trees, its walls woven from threads of life older than memory. And while this great organism works in silence, it is far from mindless. Within its web, faint electrical pulses move from thread to thread, quiet signals that rise and fade like a heartbeat. These are not the impulses of a brain, but they serve a similar purpose. Through these microcurrents, fungi send information about nourishment, about drought, about danger. The rhythm of the pulses shifts depending on what the fungus encounters, as if encoding messages in frequency and timing. Some researchers call this communication the language of the soil, and it is tempting to agree. In their way, mushrooms are speaking not with words, but with currents of life flowing through invisible wires. One tree may share sugar with another through fungal threads, or warn its neighbors when insects attack. It is an underground internet, millions of years old, built not from metal and code, but from living filaments and time. This is what intelligence looks like when it is spread thin, not a single mind, but a network of awareness diffused through earth and decay. No thoughts as we know them, yet responses, adaptations, and cooperation on a scale beyond our comprehension. The forest listens to itself through fungi, and the story of their resilience stretches even farther beyond the forests, beyond the planet itself. In the vacuum of space, where radiation scorches and temperatures drop below imagination, fungal spores have survived. Carried aboard spacecraft in scientific experiments, they endured weeks of cosmic exposure. No air, no water, no warmth, and still remained alive when brought home. It is a fact that has startled scientists and poets alike. If spores can drift through space unharmed, might life itself travel between worlds this way? The idea is called panspermia, the notion that the seeds of life could journey across the cosmos, riding meteors or dust, waiting for the right world to bloom again. In that sense, fungi are not just of Earth. They could be its ancient travelers, its messengers, its dream of continuity written into the stars. Perhaps, somewhere long ago, a spore from another world landed here, in the fertile dust of a young planet, and began to grow. Perhaps, in some distant galaxy, a cousin of that same lineage is spreading even now, beneath alien soil. If that is true, then the story of life is a story of fungi, a web that does not end at Earth's horizon, but reaches quietly into the night. And yet, even here, under the familiar sky, fungi continue to astonish. After the Chernobyl disaster in 1986, scientists searching the ruined reactor found something extraordinary: life returning to the heart of catastrophe. On the walls of the reactor's interior, where radiation still hummed, black fungi were growing, thriving in a place thought too deadly for survival. These fungi contained melanin, the same pigment that colors human skin. But in this case, the melanin did something remarkable. It absorbed radiation and transformed it into energy, much as chlorophyll captures sunlight in plants. The process has been called radiosynthesis. The mushrooms, it seems, were feeding on what we call destruction. The implications are profound. If fungi can turn radiation into fuel, they might one day help clean up nuclear waste or even shield astronauts from cosmic rays during long journeys in space. In the darkest places of the Earth, they are not defeated by ruin, they repurpose it. Where humans see danger, fungi see energy. This ability to adapt extends to the pollution of our own making. In recent years, researchers have discovered fungi that can digest plastics and oil, two of the most stubborn materials humans have ever produced. One species found in the Amazon rainforest consumes polyurethane, a plastic that lingers for centuries. Others can break down petroleum, turning black slicks of waste into harmless soil. Imagine landfills shrinking, not by machines, but by quiet colonies of fungi slowly feasting on what we leave behind. Picture coastlines once fouled by oil blooming again, restored by invisible hands beneath the sand. In their patient way, fungi remind us that nature is still capable of repair if only we allow it the time and space to work. They are the original recyclers of the earth, turning decay into possibility, pollution into peace. But in the same breath that they heal, fungi can also harm. Among their number dwell some of the most lethal organisms known, silent assassins disguised in simple beauty. The death-cap mushroom, Amanita phalloides, looks almost innocent. Pale green cap, delicate stalk, elegant symmetry. Yet within its tissues hides a toxin so potent that even a small taste can destroy a human liver. Throughout history, this mushroom has claimed kings and peasants alike, its fatal charm hidden behind its calm appearance. There is no antidote, only time and chance. It is nature's reminder that beauty and danger often share the same face. In the soft gleam of its cap lies both wonder and warning, the forest's quiet lesson that reverence must always accompany curiosity. Still, not all mushrooms threaten. Some, in fact, delight. In the deep woods and along mossy logs grow species known for their uncanny flavors. The lobster mushroom, bright orange and sweet, with the scent of the sea. And the chicken of the woods, whose layered fans tear apart in white, tender pieces that taste uncannily like poultry. These are the culinary chameleons of the fungal world, shaping themselves into echoes of the animals they are not. To taste them is to realize how deeply intertwined life can be. The forest floor becomes a kitchen, the air filled with the scent of both earth and harvest. It is as though the fungal kingdom, with its endless creativity, decided to mimic the living creatures it sustains, not through imitation, but through alchemy. In every bite, the line between plant and animal, soil and flesh, fades. What was once decay becomes nourishment. What was once unseen becomes delight. From the vast honey fungus sleeping beneath Oregon to the microscopic spores drifting through space, from deadly toxins to the flavors of comfort, fungi reveal themselves as a paradox of extremes. They are the builders and the breakers, the healers and the killers, the humble and the immense, and through it all, they whisper the same message that life, in all its forms, is not a ladder but a web, woven through light and darkness alike. In that realization lies a kind of peace. The world is not divided between what lives above and what lies below. Everything is connected by roots, by air, by threads too fine to see. The fungi have always known this. They have been telling us for 1 billion years, waiting patiently beneath our feet for us to listen. Long before science gave mushrooms their Latin names, long before microscopes revealed their hidden filaments, ancient peoples already sensed something otherworldly in them. In the far north, among the snow-covered plains of Siberia, shamans gathered bright red mushrooms speckled with white Amanita muscaria, the fairy tale toadstool. They would dry the caps over a fire, drink their infusion, and drift into visions that blurred the boundaries between earth and sky. To them, these mushrooms were sacred messengers, vessels through which spirits spoke. Half a world away, in the mountains of Mesoamerica, the Aztecs called their sacred fungi Tionanacatl, the flesh of the gods. Consumed in ceremonies of trance and revelation, they were believed to open the door between human perception and divine wisdom. Priests, poets, and rulers sought them to glimpse the unseen order behind life itself. In those candlelit rituals, the heartbeat of the earth seemed to echo through human minds. Across cultures, the message was the same. Mushrooms were not merely food, but thresholds. They emerged suddenly from the soil after rain, as if conjured by invisible hands, reminding humanity of the thin veil between worlds. When eaten, they could dissolve that veil entirely, allowing travelers to wander through realms of color, memory, and meaning beyond language. In this way, the fungal kingdom became a spiritual bridge, neither light nor darkness, but the twilight in between, where transformation begins. Even now, in quiet corners of science and psychology, researchers study the same substances once used in those ancient rites, seeking to understand how they alter the mind, how they silence fear, and awaken connection. The language has changed, but the mystery remains. Mushrooms still whisper that consciousness, like the forest, is a web, and through it, everything touches everything else. But not all the powers of fungi lead upward toward enlightenment. Some descend into the darker lessons of survival. Deep within tropical forests, where humidity drips from the leaves and insects patrol the branches, another kind of magic unfolds, one that blurs the line between life and death. Here lives the genus Cordyceps, the so-called zombie fungi. A single spore lands on an ant's back and begins its quiet invasion. Invisible filaments spread through the insect's body, threading muscle and tissue while leaving the brain intact. The ant continues its routine, unaware of the change taking root inside it. Then, one day, a strange impulse seizes it, a compulsion to climb. Step by step, it ascends a branch, stopping at precisely the right height, where temperature and humidity are perfect for fungal growth. There, it clamps its jaws onto the leaf vein and waits. The fungus consumes the rest of its host from within, then bursts outward, sprouting a slender stalk from the ant's head. From that stalk drift a new storm of spores, carried by the forest breeze to find other unsuspecting bodies below. The cycle begins again, perfect in its precision, unsettling in its elegance. To witness it is to realize that evolution is not gentle, it is ingenious. Life does not simply compete, it choreographs, it manipulates, it invents. The Cordyceps fungus turns survival into art, using another creature's motion to carry its story forward. The ant becomes both victim and vessel, a moving bridge between death and new life. In this strange theater of the forest, the curtain never truly falls, it only transforms. Yet fungi do not always single out individuals. Sometimes they shift the fate of entire species. In the late 20th century, biologists began noticing a quiet catastrophe. Frogs, toads, and salamanders across the world were dying, their skin thickening, their bodies weakening, their voices silenced. The culprit was a microscopic fungus called Batrachochytrium dendrobatidis, or simply BD. This fungus infected the skin of amphibians, disrupting the delicate balance that allows them to breathe and absorb water. Whole populations vanished within years. Entire forests fell silent at night, their chorus of croaks and trills erased. It was one of the most devastating diseases in recorded history, a fungal pandemic that rewrote ecosystems. To understand fungi is to accept this duality. They are not villains or heroes. They recycle and they destroy. They sustain forests, and sometimes they end them. Through them, nature reminds us that creation and decay are not opposites, but partners in an eternal dance, each shaping the other in turn. Even as some species perish, others thrive because of the same invisible kingdom. Every breath you take carries the proof. The air around us is alive with fungal spores, billions of microscopic travelers floating through every cubic meter. They drift across continents, ride raindrops, and rise on warm currents to the stratosphere. At any given moment, you are inhaling fragments of the forest, tiny seeds of the hidden world. Most go unnoticed. Your lungs filter them, your immune system greets them, and still they pass silent visitors, linking you to distant mountains, to oceans, to soil that may have never known your name. In a single breath, you might carry spores from an ancient pine forest or from a mossy log 1,000 miles away. The atmosphere itself becomes an invisible ocean of life, an unending migration of dust, memory, and renewal. Sometimes, scientists have found spores floating more than 20 miles above the Earth, suspended where clouds are born. There, they act as nuclei around which droplets gather, helping to form rain. It means that fungi do not only recycle the soil beneath us, they help summon the water that feeds it. The forest and the sky are in conversation, exchanging messages through microscopic travelers. When rain falls, it may be the forest calling itself home. And beneath that forest, another conversation continues slower, older, written in stone. On bare cliffs and mountain peaks, fungi meet algae in one of the oldest partnerships on Earth. Together, they form lichen, a fusion of two life forms that can live where neither could survive alone. The fungus provides structure and shelter. The algae capture sunlight and feed them both. Over centuries, lichens secrete mild acids that etch the rock beneath them, breaking it down grain by grain. What begins as a barren surface becomes, over time, the first soil, the cradle for moss, grass, and eventually trees. It was likely this partnership that prepared the continents for life after the seas receded. In their patience, lichens wrote the prologue of every forest. They are the planet's original gardeners, turning mountains into meadows, one molecule at a time. If you ever find yourself high on a wind-swept ridge, where only patches of green and grey cling to stone, you are standing in the presence of those quiet pioneers. The air may feel empty, but under your fingertips is the slow pulse of creation itself. And sometimes, creation draws its own shapes in the grass. Step into a meadow after rain, and you may find a circle of mushrooms forming a perfect ring. Folklore calls these fairy rings traces of unseen dances under the moon, where sprites and spirits once twirled. Science tells us the pattern is born from the outward growth of mycelium beneath the soil, expanding evenly as it consumes nutrients. Each year, the ring widens, and new mushrooms rise along its edge, while the center fades away. Yet knowing the mechanism does not dissolve the wonder. To see a fairy ring is to witness geometry come alive, mathematics expressed in living tissue. It is as though the earth itself sketches a symbol of eternity in the grass, reminding us that order and beauty are not inventions of the human mind, but the natural language of growth. In this way, the fungal kingdom reveals itself again, spiritual and mathematical. Invisible, yet everywhere. Ancient, yet eternally renewing. From the visions of shamans to the whispers of spores, from the patient carving of stone to the delicate symmetry of fairy rings, fungi thread through the story of life as both artist and engineer. They teach that everything spirit, soil, sky is connected by filaments we cannot see. To listen to them is to remember that the sacred is not somewhere above us. It begins right here, beneath our feet, glowing quietly in the dark. After a night of rain, when the air still carries the scent of wet soil and the trees are beaded with quiet light, something begins to stir beneath the ground. Invisible threads, long dormant, sense the touch of moisture. Energy gathers, and then, as dawn begins to breathe through the forest, the earth blooms. Where only yesterday there was emptiness, hundreds of small forms have risen, soft domes, delicate stalks, and tiny parasols pushing through leaf litter and moss. Mushrooms. They appear as if conjured. Their arrival so sudden, it feels like a miracle. In truth, they have been waiting all along. For days, months, sometimes years, the hidden mycelium beneath your feet has been weaving its quiet network, drawing sustenance from roots and fallen leaves, storing potential in its endless threads. Rain is the signal, the moment of alignment between water, temperature, and time. Then, life answers. Some mushrooms can grow an inch in a single hour, lifting pebbles and bark with silent strength. Their expansion is not a stretch or a leap, but an unfolding cells filling with water, membranes stretching like breath. It is as if the forest exhales, and these forms are that breath made visible. In them lies a meditation on patience, the understanding that stillness is not the absence of motion, but preparation for it. Every life, human or fungal, carries moments of waiting times when growth is unseen yet essential. The mushroom reminds us that transformation often happens quietly beneath the surface, until one perfect rain awakens what was always there. When morning light touches their caps, the forest becomes a gallery of subtle colors: ochre, cream, amber, soft violet. For our ancestors, these hues were more than beauty. They were art and craft. Long before synthetic pigments, people learned that mushrooms could paint the world. In the hands of early weavers and dyers, fungi became the forest's own palette. Certain species, like the dyer's polypore, released brilliant golds and oranges. Others yielded shades of olive, blue, even deep crimson, boiled with wool or silk. Their pigments bound to fibers as though the forest itself were weaving into clothing. To wear mushroom-dyed cloth was to carry the earth with you, not metaphorically, but literally. The soil's chemistry, the tree's decay, the rain's minerals, all embedded into the fibers of daily life. Even today, artisans still revive this ancient practice, celebrating the natural alchemy between biology and art. The colors shift subtly in light, just as leaves do through the seasons. Nothing artificial, nothing static, only living tones that echo the rhythm of time. From that artistry of color, we move deeper into the forest, where another kind of craft unfolds, not of beauty, but of cunning. Beneath the surface of the soil, among grains of sand and tiny roots, a silent hunt takes place. Not all fungi are gentle decomposers. Some are predators. There exist species that feed on creatures so small we would never notice them. Microscopic worms called nematodes. These fungi build traps, delicate loops of hyphae, that tighten like lassos when a worm brushes past, or sticky nets that catch it like invisible webs. Once ensnared, the fungus pierces its prey, draining its nutrients to feed the growing network. To witness this under a microscope is to watch patience turn into precision. No roar, no violence, only timing, the exact moment when stillness becomes action. Nature, it seems, does not require speed to be powerful. The fungus reminds us that intelligence can live in structure and instinct, not only in thought. Evolution, in its infinite experiments, has given even the smallest threads the wisdom to adapt, and this wisdom of design extends beyond hunting. The structure of mycelium, those countless interlocking filaments, is one of nature's most extraordinary blueprints. Light as silk, yet stronger by weight than steel, it balances strength, flexibility, and regeneration in perfect harmony. Modern scientists and architects now look to fungi as teachers. When mycelium is grown into molds and dried, it forms a dense, resilient material that can replace plastics, insulation, even bricks. It resists fire, breathes naturally, and returns harmlessly to the earth when discarded. Buildings made from fungal composites are no longer imagination. They are already rising in laboratories and experimental studios. Imagine future cities, grown instead of built domes and walls, sprouting gently from living cultures, expanding like shells or coral. Structures that protect humans while feeding the soil, materials that age gracefully rather than polluting it. The same organism that feeds trees could one day shelter us. In fungi, we see the convergence of biology and design, nature's own architecture applied to human need. And yet, their mastery of construction is nothing new. It has been unfolding since before the first leaf turned towards sunlight. More than 1 billion years ago, before there were forests or flowers or even soil as we know it, fungi had already stepped onto land. In those ancient eras, the continents were barren, rocky plains washed by primitive seas, unshaped by roots. There were no trees, no moss, no green, but there were fungi. Fossils tell us that enormous fungal structures, called prototaxites, once towered over this empty landscape. They rose as high as 20 feet, massive pillars of tissue fed by the decay of early life forms. In a world without plants, these giants stood as the first architects of land ecosystems, breaking down rock, recycling minerals, and preparing the stage for the greenery to come. Imagine that alien Earth, an orange sky, a horizon of stone and mist, and these monumental fungi standing alone, silent towers of life experimenting with form. They were not trees, not animals, but something in between. In their strange beauty, they carried the memory of the ocean's chemistry onto dry land. They were the first to bridge the divide between sea and soil. From those ancient pioneers came every forest, every meadow, every breath of oxygen we now enjoy. They transformed the planet long before our species could name it. Even now, their descendants continue that work in miniature, turning stone to soil, recycling what dies into what lives. And as they did in the beginning, fungi express their mastery through endless variety. The diversity of their forms defies imagination. Some species are so tiny, they could perch on the tip of a pin, translucent parasols that last only hours. Others, like the giant puffball, swell to the size of a beach ball, releasing trillions of spores in a single breath of wind. One forest might hold mushrooms shaped like coral, stars, cups, or antlers. Some glow with ghostly green light, others bleed crimson droplets when cut. There are species that smell like almonds, cinnamon, or rotting flesh. Each adaptation is a solution to a problem older than thought. How to survive, how to reproduce, how to endure. If you could shrink yourself down to walk among them, the forest floor would feel like another planet. You'd pass towering stems with gilled roofs, delicate domes shining with dew, threads that pulse faintly with life. The air itself would hum with spores rising like mist, a constant exchange between ground and sky. It is a microcosm of the cosmos. Infinite shapes, infinite patience. Fungi teach us that scale is an illusion. A being smaller than a grain of rice can shape entire ecosystems. A network, invisible to the naked eye, can stretch for miles. A life form with no brain can build, heal, and communicate with the elegance of a living city. In this way, the fungal world mirrors the meditative truths of existence, that complexity can arise from simplicity, that stillness hides vast motion, and that connection, not competition, sustains the flow of life. They invite us to look again at the ground beneath us, not as dirt, but as consciousness in another form. Every thread of mycelium is both root and neuron, both bridge and boundary. Each raindrop that falls awakens it. Each breeze carries its breath. The mushroom after rain is more than a plant, it is an idea incarnate, the world remembering itself, rising briefly into form before returning to the endless web below. So, when you next see them after a storm, small domes pushing through the wet leaves, glistening like stars fallen to earth, pause. Feel the quiet intelligence that surrounds you. It is the same intelligence that once turned stone into soil, that paints color onto cloth, that builds structures stronger than steel, that hunts with invisible traps, and that waits, patient as time, for one perfect drop of rain. In the fungal kingdom, life does not rush. It listens, it prepares, it transforms, and in that rhythm, slow, silent, eternal, it offers us a reflection of our own potential. Growth, after all, is not something to force. It is something to remember, because like the mushroom beneath the forest floor, we too are waiting for the right rain. The quiet moment when everything aligns, and we, too, will rise. Beneath the roots of oak and hazel trees, in the dim soil of autumn forests, lives one of nature's strangest treasures, the truffle. Unlike most mushrooms that stretch toward light, truffles hide underground, invisible to the eye, depending entirely on scent to ensure their survival. They produce an aroma so powerful and intricate that it travels through layers of soil, drifting upward to call its messengers. Wild pigs once roamed these woods with their snouts pressed to the ground, drawn by that intoxicating perfume. To them, the scent echoed the pheromones of their own kind, a signal they could not resist. In their hunger and curiosity, they unearthed the truffles, spreading the fungal spores as they went. Later, humans joined this dance, training dogs to replace pigs, companions more disciplined but equally enchanted. For us, the aroma of truffle is unlike anything else, musky, earthy, faintly sweet, a memory of the forest's breath. Chefs describe it as both primal and divine, a fragrance that transforms the simplest food into ceremony. But for the truffle, the purpose is practical, to entice, to spread, to endure. What feels to us like luxury is, to the fungus, a strategy of continuation evolution perfumed in mystery. It is a reminder that communication in nature often moves through scent, long before it ever moved through sound. The air around us is thick with invisible messages, flowers courting bees, trees warning one another of drought, fungi calling to the creatures that will carry their spores. Each fragrance is an ancient language, written in molecules and memory, and nowhere is that language more profound than in the soil itself, the great neural web that connects the roots of the living world. Beneath every forest lies an immense network of mycorrhizal fungi, partnering with tree roots in a pact older than civilization. These fungal threads reach outward, linking tree to tree, species to species, forming what scientists now call the Wood Wide Web. Through this hidden network, trees share water, carbon, and nutrients. A shaded sapling, struggling in the dark, may receive sugars from a sunlit elder nearby. A mother tree, sensing disease or the end of her life, can send her remaining strength into her offspring through fungal bridges. When pests or infection threaten, warning chemicals spread underground like whispers of alarm. To walk in a forest is therefore to walk through a living conversation, one that began long before humans learned speech. The forest is not a collection of individuals. It is one vast organism, thinking and breathing in unison, with fungi as its synapses. They translate, transmit, and balance, ensuring that life flows where it is needed most. This revelation changes how we see the world. The towering oak and the tiny mushroom are not separate entities, but expressions of the same continuity. Above ground and below, visible and unseen, they exchange what we might call care, though in their language, care is chemistry. The forest endures because it listens to itself, and as it listens, it also remembers. Through these fungal pathways, forests lock away carbon drawn from the air by their leaves. The carbon passes downward, folded into mycelial tissue, where it can remain buried for centuries. In this quiet way, fungi serve as custodians of the planet's balance, regulators of the climate's ancient rhythm. Each time a tree breathes out carbon dioxide, fungi help capture a part of it, sealing it into the dark. The process is slow but immense, one of the great unseen forces moderating the atmosphere. Without these underground storehouses, much of the Earth's carbon would drift freely into the sky, deepening the heat that now unsettles our world. It is humbling to realize that solutions to the greatest challenge of our age, the warming of our planet, are already woven beneath us. Every forest, every meadow, every field hides a secret ally. Fungi are the silent partners of climate, holding the breath of the earth in patient stillness. But the story of stillness does not mean the absence of change. In the natural world, renewal often follows devastation, and fungi are masters of that transformation. There are mushrooms that grow only in ash, pyrophilous fungi, lovers of fire. After a forest burns, when the land lies black and bare, their spores awaken. Morel mushrooms, those honeycombed delicacies prized by foragers, are among the first to rise from charred soil. Fire releases nutrients locked in wood, and the heat itself seems to whisper the signal for rebirth. Within days, the wasteland blooms with life. Mycelium threads weave through soot and ember, turning destruction into nourishment. Even the unlikeliest materials become their home. Some fungi thrive in animal dung, breaking down waste into fertile earth again. What we find unpleasant, they find abundant. They teach us that nothing in nature is truly refuse. Everything feeds something else. Death and decay are not endings, but transformations, preludes to new beginnings. When we see mushrooms on burned ground or rising from a pile of manure, we are witnessing resilience, written in biology, the power of life to reimagine itself. From ruin comes fertility, from ash comes sweetness. In these humble recyclers, the planet rehearses the same lesson over and over. To fall apart is also to make room for growth, and in that growth lies medicine. Among the countless gifts fungi have offered humanity, perhaps none has changed us more than their chemistry of defense. Long before human doctors existed, fungi were already producing antibiotics to protect themselves from bacteria. In 1928, Alexander Fleming noticed that a mold, a close cousin of mushrooms, had killed bacteria on a petri dish in his lab. From that observation came penicillin, the first great antibiotic. It was a moment when the microbial world turned healer, when one organism's self-preservation became humanity's salvation. Millions of lives were saved, wars shortened, futures rewritten, all because a fungus decided, in its quiet logic, to keep its space clean. Since then, countless other medicines have been born from fungal compounds: cholesterol-lowering statins, anti-rejection drugs for transplants, even treatments for cancer. Each discovery reminds us that the boundary between healing and harm, poison and cure, is porous, and fungi walk that boundary with perfect balance. They are nature's chemists, crafting molecules of both mercy and warning. What they make for their survival becomes our survival too. And perhaps no partnership reveals this more deeply than the one that shaped our civilization's simplest joys. Every loaf of bread that rises in an oven, every glass of wine that sparkles in the light, every frothy head of beer poured at dusk, all are gifts of fungi. Yeast, a single-celled relative of mushrooms, is the invisible worker behind these ancient miracles. It feasts on sugar and exhales carbon dioxide and alcohol. In bread, those invisible breaths puff the dough into softness, transforming grain into something alive and fragrant. In wine and beer, that same breath becomes transformation of another kind, a chemistry that turns fruit and grain into celebration. Archaeologists have found traces of fermentation in vessels older than cities, suggesting that humans discovered this partnership early in our story. Perhaps by accident, a bowl of crushed fruit left out to the air, a curious taste, a strange warmth spreading through the body, and from there, a friendship began. Humanity learned to cultivate and guide the work of fungi, turning them into collaborators in our own evolution. Through yeast, we learned patience, to wait for bubbles to rise, for time to do its invisible work. Through fermentation, we learned preservation, how to turn the fleeting harvest into something enduring. And through taste, we learned gratitude, that the smallest life forms can carry the deepest magic. So when you hold a piece of bread or sip from a cup of wine, you are sharing in a relationship millions of years old. The same processes that shape forests, heal wounds, and renew soil are the ones that lift your meal and warm your spirit. In every crumb and every drop is the echo of mycelium, the memory of decay transformed into delight. The story of fungi is, in the end, the story of connection, from scent to soil. From carbon to civilization, they remind us that survival is not solitary. Every breath, every taste, every act of renewal is part of a single conversation, one that began before we were here and will continue long after. And if you close your eyes for a moment, you might almost hear it. The whisper of roots exchanging news, the sigh of spores drifting through the air, the heartbeat of fermentation rising from grain. It is the sound of life's oldest language, chemistry turned into communion, silence turned into song. In the deep stillness of a forest, you might stumble upon something both mesmerizing and unsettling. A pale, fleshy mushroom dotted with droplets of scarlet. They glisten like blood against ivory, rich and viscous, slowly beading along the surface. This is the bleeding tooth fungus, and despite its morbid appearance, it is not dangerous to touch. The red liquid is not blood, but a sap-like exudate filled with pigments and compounds whose purpose remains partly a mystery. To look at it is to feel two emotions at once: fascination and unease. The mind hesitates, unsure whether to step closer or recoil. It resembles a wound in the forest floor, a bleeding heart among the moss. Yet in its strange design lies a kind of beauty, a reminder that nature often wears the language of discomfort to draw attention to the extraordinary. No other organism expresses this paradox quite like fungi. They turn decay into color, corruption into pattern. For every mushroom that evokes tenderness and wonder, another evokes dread, both born from the same soil, both performing the same essential task, returning life to its cycle. If the bleeding tooth stirs our curiosity through vision, its counterpart, the stinkhorn, captures the nose. These mushrooms rise from the earth in phallic shapes, coated in a greenish-brown slime that smells unmistakably of rotting meat. To humans, the odor is nauseating. To flies, it is irresistible. They land upon it eagerly, feeding on the sticky film and carrying spores to new places. What repels one species attracts another. It is a masterclass in adaptation, the fungus manipulating disgust into opportunity. The stinkhorn's grotesque perfume is not cruelty, but ingenuity, proof that in the grand experiment of life, every sense can be turned into a messenger. These two extremes, the bleeding and the stinking, are twin reflections of the same principle. Nature does not divide beauty from horror. It simply allows each to exist where it is most useful. The forest floor is both gallery and graveyard, a place where decomposition becomes artistry. The lesson is quiet but profound. The ugly and the divine are not opposites. They are two faces of the same unending process. Beneath this stage of theater and scent lies the true body of the fungus, an invisible civilization that dwarfs anything we build above ground. The mycelium network spreads through the soil like a vast city without walls, branching into streets, intersections, and corridors that move resources as efficiently as any engineered system. Through these tunnels, nutrients flow like commerce. Sugars from trees traded for minerals from the earth. Water passed along in exchange for carbon. There are storage chambers where energy waits, highways where enzymes travel, and intersections where signals meet. Scientists studying the flow of matter within mycelium compare it to the organization of urban infrastructure. But this city has no architects, no blueprints, and yet functions flawlessly. Every thread adjusts to its environment, building, breaking, and rebuilding as needed. It is as if the earth itself has constructed a nervous system that doubles as an economy. Mycelium is both messenger and market, a society without borders, running entirely on chemistry and instinct. If you were to zoom into the soil, you might see what resembles glowing constellations of light, lines pulsing as nutrients pass from one root to another. It would look like a city at night, except this one has existed for hundreds of millions of years. This invisible civilization is proof that intelligence does not require consciousness. Coordination does not require command. The mushroom teaches us that structure can arise from cooperation and balance from endless exchange. The forest survives because everything below it remembers how to share. And from this base of connection, fungi continue to surprise us not just as recyclers and architects, but as artists of transformation. Some species can change color when touched, their flesh bruising into electric blue or emerald green within seconds. The blue staining bolete, for instance, transforms its pale interior to vivid cobalt when exposed to air. The reaction is chemical, a cascade of oxidizing compounds meeting oxygen. But to watch it feels like witnessing emotion. The mushroom blushes, revealing an inner world that was invisible moments before. Other fungi play not with color, but with scent. Some release the sweetness of maple syrup when warmed by the sun. Others smell faintly of coconut, almonds, or cinnamon. The molecules that create these fragrances are close relatives to those that flavor our foods: esters, aldehydes, and ketones crafted in the quiet laboratories of decay. To lean close and inhale is to discover that the forest has a perfume, one composed not of flowers, but of fungi. Each aroma tells a story of chemistry perfected through time. Scents that attract insects, warn predators, or simply express abundance. For humans, these smells awaken memory. The warmth of breakfast, the sweetness of childhood kitchens, echoes of our own biology reflected in the soils. In this way, mushrooms are the world's first perfumers. They distill emotion into molecules, crafting invisible atmospheres of flavor and feeling. A forest after rain is not merely alive. It is fragrant with the breath of fungi, a tapestry of scents as complex as any symphony. From their ability to color and perfume comes another astonishing kinship: the shared use of sunlight itself. Like us, fungi can create vitamin D when exposed to ultraviolet light. When the sun touches their surface, a compound called ergosterol transforms into vitamin D2, the same nutrient that strengthens human bones and supports immunity. This small act of chemistry bridges an enormous divide. The same star that nurtures the forests also nourishes the beings that decompose them. Life and death are both powered by light. The mushroom's cap, pale or brown, becomes a miniature solar panel, storing the sun's energy not for photosynthesis, but for sustenance. In the grand dialogue of existence, fungi are translators between darkness and illumination, feeding on shadow, yet thriving in the trace of light. Perhaps that is why some of them, even the most poisonous, choose to glow. Deep in tropical forests, you might find a log faintly illuminated at night, edges traced in green fire. Look closer, and you'll see the source. Bioluminescent mushrooms shimmering softly through the dark. Their light is created by a reaction between two substances, luciferin and luciferase, the same chemical duo responsible for the glow of fireflies and deep-sea creatures. Scientists believe this radiance serves several purposes. It may lure insects that help spread spores, or deter animals that might eat them. Yet beyond function, it is an aesthetic miracle beauty born in decay. These luminous fungi are the lanterns of the forest, burning without flame, transforming rot into radiance. To stand among them is to feel you've entered another world, one where gravity seems to sleep and silence hums with light. The air feels charged, almost sacred. Even knowing the chemistry does not dissolve the wonder; if anything, it deepens it. The idea that a fungus can turn death's residue into living glow feels like a revelation whispered by the earth itself. There, in the quiet between trees, you begin to understand. The same principle that drives the stinkhorn's stench also fuels this ethereal brilliance. Every adaptation, from the grotesque to the divine, is an expression of survival, life's endless experiment in communication. Whether through scent, color, or light, fungi remind us that expression is not exclusive to emotion. Even decay has its voice, and it speaks in chemistry. The bleeding tooth, the stinkhorn, the blue-staining bolete, the glowing caps in the night, all are verses in the same long poem of existence. Together they tell us that creation is never one-sided. Beauty requires contrast. Light requires shadow. And death, in the patient logic of the forest, is simply the body's way of becoming useful again. When you breathe in the scent of rain on soil or catch the faint shimmer of bioluminescence in the dark, you are witnessing that balance at work, the world renewing itself through transformation. The mushroom is both the decay of yesterday and the promise of tomorrow. It bleeds, it stinks, it glows, it feeds, it endures. And as you watch the light fade and the forest return to stillness, you might feel what countless generations before have felt: a quiet awe, a sense of being part of something larger, older, and infinitely patient. For beneath your feet, beneath every fallen leaf and buried root, the same intelligence hums, weaving color, scent, and light into a single truth: that nothing in nature is wasted. Nothing in life is ever truly gone. It only changes form again and again, until even death begins to shine. Beneath the ground we walk upon, there exists a kind of memory, not the conscious recall of thought, but the quiet intelligence of pattern. Within the threads of mycelium, every experience leaves a trace. When the soil dries, the network learns to conserve moisture. When the seasons shift, it adjusts the rhythm of its growth. Later, when those same conditions return, it remembers. This memory is not written in words or neurons, but in the subtle architecture of living threads. The pathways of the mycelium change, shaping themselves in response to experience, the way rivers carve valleys after rain. It is a biological recollection, the Earth's own neural map of what has come before. Some scientists call it environmental imprinting. Others call it adaptive intelligence. But to stand quietly in a forest and feel the pulse of the soil is to sense something deeper, the awareness of the land itself, learning from time. Through these living circuits, the ground becomes its own teacher. Each generation of fungi inherits the wisdom of the one before, encoded not in DNA alone, but in behavior. A memory of droughts survived, nutrients found, storms endured. It is as though the forest floor is a vast, thinking skin, remembering the weather, the footsteps, the history of every life that has passed above it. And this memory extends even into the places where we imagine life could not exist. Beneath the weight of ice, in landscapes locked in winter for most of the year, fungal threads continue their patient work. In frozen forests, they sleep within tree roots, awakening only when the brief thaw comes. In the Arctic tundra and beneath glaciers, spores wait centuries, perhaps millennia, for a single moment of warmth. Some species have learned to survive being frozen solid. Their water turns to ice, their cells fall into stillness. And yet, when the world softens again, they return alive, unchanged. Others inhabit deserts, clinging to rocks and surviving on mist alone. In the Atacama, where rain may not fall for decades, fungi live within grains of salt, drawing what little water they can from the thin breath of night air. To encounter such resilience is to confront the quiet truth that life is not fragile. It is adaptive, elastic, and astonishingly inventive. Where we see limitation, fungi see opportunity. Where we imagine lifelessness, they persist in ice, in stone, in air so dry it burns the lungs. They are the heartbeat beneath stillness, proof that existence always finds a way to continue its own story. For millennia, humans have sensed that this hidden strength could be borrowed, and so we turn to fungi as healers. In the forests of China and Japan, the reishi mushroom, known as the mushroom of immortality, was gathered for centuries as a symbol of vitality and long life. It appears on ancient scrolls and temple carvings, a curved red cap signifying peace and renewal. Its chemistry strengthens the immune system, calms inflammation, and nourishes the body as though lending it the patience of the earth itself. In Japan, shiitake mushrooms were once reserved for nobility, valued not only for their flavor but for their power to restore energy. Across the mountains of Asia, herbalists brewed teas from their dark, fragrant caps to sustain strength through the changing seasons. These traditions, passed through generations, became the early dialogue between humans and fungi, intuition preceding science. And now, in the age of microscopes and molecules, that ancient wisdom is being confirmed. Modern research reveals that compounds within these mushrooms can modulate immunity, lower cholesterol, and support longevity. Among them, one stands out for its promise: the lion's mane mushroom, a white cascade of icicle-like spines that seems to glow softly even in shade. Within its fibers are molecules known as hericenones and erinacines, which stimulate the growth of nerve cells. In laboratories, scientists have watched these compounds awaken dormant neurons, helping to repair damaged pathways in animal brains. Early studies hint at possibilities for treating memory loss, anxiety, and neurodegenerative disease. What traditional healers once called medicine for the spirit may, in truth, be nourishment for the mind itself. It is as if fungi, the ancient architects of memory in the soil, now offer humanity a key to remembering our own inner landscapes. The same network that helps a forest recall the rhythm of rain teaches us that renewal, even in the most complex systems, is always possible. Yet their most enduring gift is not only healing, but housekeeping. Every autumn, when leaves fall and branches break, fungi begin their slow and sacred labor. Without them, the planet would drown in its own abundance. Trees would topple and never return to dust. Bones would lie unbroken, and the cycle of nutrients would grind to a halt. Fungi are the world's quiet recyclers, releasing powerful enzymes that dismantle the toughest molecules in wood and leaf. They transform what seems permanent into something porous, returning it to air and soil. Lignin, cellulose, keratin, the sturdy scaffolding of life, all dissolve under their patient chemistry. When you walk through a forest carpeted in fallen leaves, you are walking over a slow miracle of digestion. Every soundless flake of decomposition is a conversation between fungi and the world, between endings and beginnings. Through this process, the nutrients that once formed tree and feather and flesh return to the soil, to be drawn up again by roots and reborn into new life. It is humbling to realize that the air we breathe depends on this unseen labor. Without the work of fungi, the carbon stored in organic matter would remain trapped, the atmosphere would thin of oxygen, and the renewal of ecosystems would cease. Every green leaf owes its existence to countless fungal ancestors that turned the past into soil. So when we speak of decomposition, we are really speaking of balance, the unbroken circle of return. The mushroom is not merely an emblem of decay, but of transformation. In its slow dissolution of matter, the earth remembers how to stay alive. Perhaps that is the greatest memory of all, not the recollection of details, but the persistence of pattern. To endure, to adapt, to turn loss into nourishment, these are the teachings of fungi. They are the keepers of continuity, the caretakers of renewal, and the living memory of the planet itself. And as their threads weave through darkness, recycling what once was into what will be, they remind us that nothing is ever truly gone. The world, like the mycelium, is always learning from its past and always beginning again. By day they disappear. Their caps match bark and leaf and loam so closely you could kneel beside one and never know. But when darkness drifts between the trunks, the forest raises its own small lamps. Mushrooms pulse to life in soft greens, sea glass blues, pale honey yellows. The light is quiet, like breath. It doesn't flood the paths or throw shadows against the trees. It gathers close to the ground, beading along moss and rotting wood, outlining the seams where life is turning back into soil. The glow is chemistry, not sorcery. Luciferin meeting Luciferase, oxygen joining the dance. A trick of electrons learned by fireflies and borrowed by fungi. Yet under a new moon, it feels like the forest has remembered an older language. You look down and the earth looks back, calm, luminous, deliberate. One step at a time, your eyes adjust, and a hidden kingdom writes itself in light. No wonder the stories came. Travelers once called it fairy fire, foxfire, the lanterns of spirits who led wanderers astray or safely home, depending on the tale and the night. These lights wake only after the stars appear, as if the forest keeps a curfew on wonder. The line between what is seen and what is believed gets thin out here, thin enough to step across. You don't need to choose between myth and science. The glow is both a measured reaction and a good omen, proof that decay can shine, and that the dark is not empty. Clinging to stone and bark are creatures that are not one thing but two. Lichens are a pact written in living threads. Fungi building shelter, holding moisture, shaping the microclimate. Algae or cyanobacteria harvesting light and making food for the union. Together they colonize the nearly impossible wind-scoured cliffs, Arctic tundra, the backs of old gravestones. They color the world in quiet patches: sage, sulfur, rust, sky. If mushrooms are lanterns, lichens are workshops. They soften rock grain by grain, tease minerals free, and start the long conversion of stone into soil. This is cooperation older than forests. It's agriculture without plow or fence. The fungus tends the farm, the algae keeps the lights on. In places where almost nothing can live, partnership goes first. Not every gift reveals itself raw. Some mushrooms are only food after fire. Morels pucker like honeycomb. Shiitakes open like firm umbrellas. Both can trouble the stomach when uncooked. Both transform when warmed. Heat unwinds stubborn molecules, tames small toxins, loosens walls so aroma and nutrients can move. The pan becomes a key. Foragers learn the etiquette of this transformation, the way sailors learn currents by attention paid over years. Clean the caps, slice with care, saute slowly. The scent rises first: wood, rain, a touch of nut. Then the texture finds itself, tender but springing back. The lesson is simple and deep. Respect changes matter. What you feared becomes nourishment. What seemed closed opens, one quiet hiss of steam at a time. Some mushrooms announce no the moment they touch the tongue. The bitter bolete looks like a cousin to dinner, yet turns a dish harsh with a single bite. That edge is not a mistake. It's a message. Bitterness in the wild is a velvet rope across the wrong door, a chemical civics lesson. This is not for you. Still, the body you won't saute is working for you anyway. It is sorting wood into soil, returning leaves to their elements, feeding the web you stand upon. In that sense, bitterness is a kindness. It keeps you safe and keeps the system running. Not every path is ours. Not every flavor is meant to please. Boundaries can be elegant. Within some caps, the forest tucked a different kind of chemistry, one that edits perception itself. Psilocybin and its kin have been prayer and taboo, danger and medicine. In ceremonies from old Mesoamerica to modern therapy rooms, these molecules tilt the inner lens. Time loosens, patterns braid, the self becomes porous to the world outside it. For some, that shift is terrifying. For others, it's a relief, almost beyond language. What was once whispered in ritual is now measured in scans and scales. Researchers test whether a carefully guided session can dislodge the ice of depression, soften anxiety's grip, interrupt addiction's loop. Nothing here is casual. Set and setting are not cliches, but rails. The same depths that can drown can also cleanse. In caves across Spain and the Sahara, ancient figures hold shapes that look like mushrooms. Whether they are or not, the implication stands. Long before labs, humans suspected that the forest could open doors that lead inward. There is another door, a practical one, where fungi meet design. Feed agricultural waste to mycelium, guide its growth in a mold, then dry it. The result is a foam-like material that cushions like polystyrene, insulates like it, protects like it, then composts away when the job is finished. The circle closes, field to box to field again. Nothing eternal, nothing stranded in oceans, nothing ghosting down a river for centuries. Wood burns bright, plastics burn dirty. Mycelium composites, though, tend to char and settle, releasing far less of the worst fumes. The secret is in the architecture. Chitin and polysaccharides layered into a mesh that resists flame like a mind that refuses panic. Imagine walls lined with panels grown, not machined, lightweight, renewable, and difficult to ignite. Imagine furniture that, when finally worn out, doesn't haunt a landfill but returns to ground. Fire will always be with us. How we meet it can change. Reach for a jacket. Imagine it grown in weeks. Myco-leather begins as mycelium encouraged to knit itself into sheets, then tanned and finished with textures you can dial like a radio. Suede soft, satin smooth, matte or gloss. It breathes. It flexes. It lasts. And when its life is done, it does not ask the earth to hold it forever. This is where aesthetics, ethics, and durability stop being rivals. We are used to materials that cost the planet something it can't afford. Water, years, habitat, lives. Here is a different ledger. A material drawn from the same network that feeds forests, designed to serve and then to leave no wound. It feels almost like science fiction until you touch it. Then it feels like common sense we forgot and just remembered. Walk the timeline back through these scenes and a pattern appears. In the dark, the forest shows you how to live, glow without spectacle. The bioluminescent mushroom doesn't flood the understory. It marks the seam where work is happening. Lichen doesn't conquer with speed. It persists with partnership. Heat doesn't punish. It refines. Bitterness doesn't scold. It signals. Molecules that could be reckless become instruments in careful hands. Waste becomes resource. Fire is met with structure, not only suppression. Luxury unhooks itself from harm. Underfoot, the mycelium carries these lessons on threads too fine to see. We think of intelligence as a head thing, as neurons under bone. But the forest keeps showing us other ways to know. To network is to decide where to grow and where to stop, to root around damage, to share what is extra and borrow what is scarce. To glow is to communicate. To taste bad is to draw a line without a fight. To be edible only after cooking is to collaborate with another species in a ritual as old as hunger. We live on a planet that is always taking itself apart and putting itself back together. Fungi sit at the hinges of that motion. They house the sun in lichen farms hung from the first ledges of land. They turn logs into loam, and loam into lilies. They craft aromas that pull insects across fields, colors that filter light, textures that hold water for seedlings that didn't ask for a drought and get one anyway. They are rigor without rage, patience without passivity, generosity without applause. So when you see a green lamp on a fallen branch at midnight, or a grey crust on a granite face that winter forgot to wipe clean, know that you are looking at tools, not decorations. And when a pan hisses and an unpromising cap becomes dinner, know that you are participating in an ancient negotiation heat for safety, attention, for abundance. When a designer snaps a mycelium panel into a frame, or flexes a sheet of grown leather that never knew a scream, it is the same negotiation at another scale. Give the organism what it needs, guide its growth, listen for the limits it asks you to respect, take only what can be returned. The atlas we're building here is not just a map of facts. It's a map of behaviors copied from a kingdom that rarely raises its voice. If you'd like a motto to carry out of the trees tonight, take this: glow gently, cooperate early, transform responsibly, and leave nothing stranded. That's the mycelial way. And the way home, under lanterns that rise from the moss, is easier when you move like that. slow, sure, and almost invisible, until it's time to shine. When winter comes, most of the forest slows to a whisper. Water hardens, cells stiffen, and the small machinery of life waits for spring's permission to move again. But in the frozen ground, the fungi continue their quiet labor. Within their filaments are sugars and proteins that bend the rules of physics, natural antifreezes that keep ice from forming inside their cells. Water can chill but not crystallize, and that difference is everything. It means that even in the heart of frost, decomposition continues. Logs soften, leaves darken. The slow conversion of death into soil never truly stops. These antifreeze compounds don't just protect the fungi, they protect the rhythm of the earth itself. In agricultural labs, scientists study them, hoping to borrow their design for crops threatened by cold snaps, or for roads and runways that need to shed ice without salt and smoke. What the mushroom does by instinct, we try to copy with formulas. Somewhere beneath the snow, chemistry older than language is still working, holding a tiny flame of motion in a world gone still. Yet the story of fungal resilience goes deeper than ice. It reaches into stone. Some species release faint acids that coax minerals from rock, calcium, magnesium, potassium, turning what once seemed lifeless into soil. This process, nearly invisible, is the geological equivalent of breathing. Molecule by molecule, they feed on the mountain's patience, digesting minerals that plants will one day drink. You can think of them as miners, or as sculptors, or as the planet's first chemists, teasing the raw elements into forms that living systems can use. When we speak of technology, we often imagine speed and metal and code. But fungi remind us that invention can also be slow, damp, and deliberate. Their biomining doesn't scar the land or poison rivers, it simply waits. The art of extraction here is gentleness, pressure applied over centuries, knowledge written into enzymes instead of patents. The lesson hides in plain sight. Patience is not the absence of power, but another form of it. Some powers, though, seem beyond comprehension. In the abandoned ruins of Chernobyl, where radiation still hums in the bones of the buildings, mushrooms have begun to grow. They are dark, thick-skinned, rich with melanin, the same pigment that colors our hair and eyes. But here, melanin does more than protect. It converts. In a phenomenon scientists call radiosynthesis, these fungi use radiation as energy, turning what would kill most life into a food source. Imagine that, a creature that feeds on catastrophe, weaving nourishment out of fallout. It's as if evolution, facing disaster, simply shrugged and said, "Try again." Researchers now explore how these same melanized fungi might shield astronauts from cosmic radiation or detoxify nuclear waste on Earth. The idea sounds like science fiction, but the precedent is already glowing faintly in the rubble. Life, even here, refuses to end. It changes its diet. That adaptability is not new. Hundreds of millions of years ago, when the first green shoots tried to leave the ocean, the land they met was bare stone, no soil, no shelter, no network of roots. Waiting for them were fungi. They formed alliances with those pioneering plants, wrapping their roots in threads, extending them into the rock to fetch nutrients in exchange for sugars. Together they built the first thin skin of soil, the living crust that would become fields and forests. Without fungi, plants might have never left the sea. Without plants, animals would never have followed. Every step across a meadow today is a quiet act of gratitude. Beneath the grass, the same kind of partnership hums on. The modern forest is standing on a foundation laid by fungal ancestors, threads that once bridged water and stone, that still carry whispers of that first handshake between kingdoms. Even the oceans hold their kin. Far below the waves, marine fungi live entwined with coral, threading through the skeletons of reefs. They help balance nutrients, fend off disease, perhaps even strengthen coral against warming seas. These partnerships are only beginning to be studied, but they suggest that the fungal kingdom never truly left the water. It simply learned to adapt wherever carbon breathed. If corals are architects, Fungi are caretakers, maintaining the structure from within. In the shimmer of salt water, you can almost see the same logic that governs a forest. Cooperation as architecture. Damage. They don't despair. They simply begin. In their way, they teach the same lesson as the glowing fungi of the forest night. Transformation is the only constant. And the only true defense against disaster is participation in the cycle that follows. Consider what this means for us. We think of survival as resistance, shielding ourselves, insulating, fighting back. But fungi show another path. They don't resist the cold, they adapt their chemistry. They don't blast mountains apart, they dissolve them gently. They don't fear radiation, they redirect it. They don't run from contamination, they eat it. Their power is not in defiance, but in fluency. They speak every dialect of matter, and in doing so, they find ways to continue. If you could see the world through their tempo, the planet would appear not as a battlefield, but as a slow conversation of elements. Ice and melt, stone and spore, decay and bloom. The fungi mediate that conversation, translating between realms. They are not conquerors of extremes, but interpreters of them, turning danger into data, hardship into habit. In a way, they are the memory of adaptation itself. From the moment life left the ocean, fungi have been there, making introductions between minerals and roots, between darkness and light, between destruction and renewal. They build the corridors that other species travel without ever noticing. The mycelial network beneath your feet is older than trees, older than the soil that holds them, older even than the first breath of oxygen-rich air. It remembers every storm, every drought, every shift of climate in the planet's long memory. To study them is to study persistence. To walk among them is to glimpse resilience, not as triumph, but as harmony. Survival by participation, not domination. In their patient chemistry, you can read the future as well as the past, a blueprint for how life might endure on an increasingly unpredictable planet. So when the frost returns, when rain carries dust across oceans, when waste darkens the fields, the fungi will still be there, working beneath the surface. Their antifreezes will hum, their acids will gnaw softly at the stone, their spores will lift into the weather, their filaments will draw out the poison, stitch new soils, and wait for roots to come. And maybe that is the quiet faith the earth has always kept in them, that no matter what happens above, in the noise and haste of human time, below there is a patience that does not break. The same patience that turned radiation into food, that pulled rock into soil, that helped the first green thing stand upright in the wind. We tend to measure civilization by how fast we can move, how much we can build, how loudly we can declare progress. But perhaps the true measure is how well we can learn from the organisms that do everything we try to do. Cool the heat, heal the wounds, recycle the past without leaving scars. Beneath every frozen field and glowing forest, the fungi continue their work. Slow, invisible, tireless. The earth breathes through them, and through that breath comes the simplest instruction any species could hope for: adapt, connect, and begin again. In the aftermath of an oil spill, the world seems to stop breathing. The slick black film chokes the water, the soil clings to poison, and silence replaces the flutter of wings and the hum of insects. Yet, beneath that quiet devastation, life is already beginning its slow, invisible repair. Fungi arrive first. They extend their threads into the contaminated ground, sending enzymes outward like searchlights. These molecules are chemists beyond our ability to imitate. They pry apart the tight carbon chains that make oil and diesel so enduring, breaking them into smaller, harmless fragments, simple sugars and fatty acids that other microbes can eat. Weeks later, the black surface begins to dull, then fade to brown, then to green. Shoots rise from what looked like ruin, and with them come beetles, then birds, then the pulse of a returning ecosystem. The process has a name: mycorremediation, but the word feels too clinical for what it really is. The planet teaching us that healing need not come from machines or fire or force, but from patience. A single spore, multiplied 1 billion times, can turn a poisoned landscape into a garden again. It is humbling to think that the same organism we step over on a forest path might also be the key to repairing our worst mistakes. But that is the way of fungi, to turn damage into nourishment, to rewrite endings as beginnings. Some of their gifts arrive not as miracles of chemistry, but as simple sensory surprises. Deep in the woods, there are mushrooms that smell faintly of chocolate, soft, sweet, and entirely unexpected. Their fragrance comes from molecules almost identical to those that give cocoa its comforting warmth. To encounter it among wet leaves is to feel the forest smile back at you, reminding you that pleasure, too, has a place in the cycle of decay. Nature's dessert course, served without warning. And then, as night falls, another wonder begins. From the bark of fallen trees or the underside of rotting logs, a green glow seeps into the dark. The bioluminescent fungi of the tropics are small, some no larger than a coin, but their light can be seen from yards away, a spectral shimmer like moonlight trapped in wood. For centuries, travelers told stories of foxfire and fairy lamps, of spirits who walked the forest after midnight. Science now knows the truth. The glow is a chemical conversation between luciferin and luciferase, oxygen and enzyme. The purpose may be practical, drawing insects to spread spores, but its effect is pure wonder. The forest doesn't need electricity, it makes its own lanterns. That same ingenuity once reached unimaginable scale. Hundreds of millions of years ago, before trees ruled the land, fungi did. Towering columns called prototaxites rose nearly 30 feet into the air, their trunks built of layered filaments, their crowns shading a landscape of moss and ferns. To the few early creatures that crawled among them, these giants must have looked like pillars holding up the sky. They were the first architects of terrestrial life, turning rock into soil, shading the ground, and preparing the world for the forests that would follow. When the first true trees finally grew, they did so in the footsteps of fungi. The builders yielded to the builders-to-be. Even today, fungi practice the art of patience that once raised those ancient towers. Some species can dry themselves to dust and wait years for the rain to return. Their cells fold inward like origami, locking water away, slowing metabolism to almost nothing. To the eye, they look dead, a brittle husk, a forgotten crust on stone. But add moisture, and they wake as if no time has passed, resuming the sentence they left unfinished. In deserts and tundras, this ability is life itself. A strategy of trust in the rhythm of the world, faith that the next drop will come. It is the same resilience that makes fungi the perfect travelers beyond Earth. When scientists sent spores into orbit, through vacuum, microgravity, and radiation, they did not wither. They grew. They adapted. Some even altered their chemistry, thickening their walls, adjusting their pigments, as if to say, "We've been to worse places." In the future, astronauts may rely on them to recycle waste, to grow food, to build structures from living material that strengthens itself with time. In a world without air or rain, fungi could still weave shelter. They have done it before, on a younger, harsher Earth. The prospect of them helping us colonize other planets feels less like invention and more like remembering. Their partnerships here on Earth continue to define our survival. Beneath every field of wheat, corn, or rice lies a hidden collaboration. The roots of crops intertwine with threads of mycorrhizal fungi, an underground alliance that has lasted for hundreds of millions of years. The fungi extend the plant's reach, carrying water and minerals in exchange for sugars. They also whisper signals of defense. When a pest attacks one plant, chemical warnings travel through the network, priming the immune systems of its neighbors. To the farmer, the crop stands alone in neat rows. To the fungi, it is one vast organism, linked by filaments that pass both food and news. Modern agriculture, weary from its own excess, is beginning to listen. Some farmers now seed their soil with beneficial fungi instead of pesticides, letting these quiet allies do what chemicals never could: restore balance. A healthy network below can mean fewer diseases above. A farm that cooperates with the microbial world becomes less a factory and more a living landscape, resilient instead of dependent. Medicine, too, owes an unpayable debt to the fungal kingdom. From the molds and mushrooms of the forest have come some of humanity's most powerful compounds. Statins that lower cholesterol, cyclosporine that allows organ transplants to succeed, and anti-cancer agents that slow the multiplication of malignant cells. Each discovery feels like an echo of ancient reciprocity, a repayment from the organisms that kept the first ecosystems alive. The story of penicillin is the perfect emblem of that generosity. In 1928, Alexander Fleming noticed that a stray mold had killed bacteria on a forgotten petri dish. From that accident came the world's first true antibiotic, the beginning of modern medicine. Millions of lives were saved, not by invention, but by observation, a human noticing what the fungus already knew. In that moment, the boundary between lab and forest blurred. What grew in shadow became our shield. It's almost poetic that the same kingdom that decomposes our world's waste also keeps our species alive. Fungi cleanse the soil, and they cleanse our blood. They recycle forests and repair human hearts. They do not distinguish between ecosystems and bodies. To them, both are networks in need of balance. The same principle extends to the kitchen, where yeast, the single-celled cousin of mushrooms, turns daily life into celebration. Every loaf that rises in an oven, every glass of wine that shimmers in candlelight, is the result of a microscopic alchemy. Sugar transformed into air and spirit. Yeast eats and exhales, and in that gentle breath lies civilization itself. A sourdough starter is its own small cosmos. Wild yeasts live beside friendly bacteria, shaping flavor through their delicate negotiations. Bakers learn to read it by scent and sound the soft hiss of gas, the sweet-sour perfume of fermentation. In its rhythms, you can hear echoes of the forest floor: cooperation, timing, transformation. Winemakers, too, speak of terroir, not only in soil and sun, but in yeast, the local strains that bend grapes toward individuality. Fermentation is chemistry, but also choreography, a dance between biology and patience. The fungi take sugar and teach it how to become something more. Nourishment, intoxication, communion. This quiet partnership has guided human history for as long as we've had fire and hunger. Bread and wine, beer and cheese, soy sauce and miso, all are collaborations with fungi. They remind us that civilization is not a triumph over nature, but an alliance with it. And perhaps that is the clearest thread running through all these stories: the humility of power. Fungi do not shout their influence. They mend what we destroy, flavor what we eat, heal what we break, and light what we fear. They thrive in darkness, yet teach us about light. They live in decay, yet sustain our health. They move so slowly, we almost forget they are there, until suddenly the world changes because of them. Picture the sequence again. An oil-black wasteland turned green, a forest glowing from within, a prehistoric column taller than a house, a spore drifting through space, a field of grain fed by invisible hands, a medicine vial labeled penicillin, a loaf rising golden in a baker's oven. All of it, one story told, in many dialects, the story of transformation through relationship. To see the world through fungal eyes is to see that everything is provisional. Ruin becomes resource. Endings become entrances. What we call decay, they call dinner. What we fear as poison, they metabolize into life. The mushroom never asks whether a place is pure or tainted. It simply begins the work of connection. So let us imagine the planet, not as a hierarchy, but as a network. The forest, the farm, the city, the human body, all stitched together by threads of cooperation. The fungi have been writing this pattern for 1 billion years. We are just now learning to read it. Somewhere beneath our feet, enzymes are still dismantling oil, turning black back to green. Somewhere above the clouds, spores are drifting, seeding rain. In laboratories and kitchens, new materials and medicines are being grown rather than built, baked rather than forged. The kingdom of fungi moves slowly, but its reach is vast. And if there's a lesson in their patience, it's this. Survival is not about strength. It's about conversation. To endure, to heal, to create, we must learn the grammar of collaboration. The mushroom already knows it by heart. It speaks in molecules, in scents, in symbioses that stretch from soil to star. We have only to listen. The next time you tear a piece of bread, or catch the scent of wine breathing open, remember what you're holding. It's not just food or comfort. It's the work of ancient companions, those quiet recyclers, architects, and healers who have been here since before the first forest, and will likely remain after the last. In their rhythm, there is no finality, only the turning of one form into another. Life, death, nourishment, decay, all are one movement, looping endlessly beneath and above the ground. And in that rhythm, if you listen long enough, you can almost hear it. The patient heartbeat of the earth, pulsing through the threads of fungi, reminding us what it means to begin again. Walk into any museum, and you'll find them there, hiding in plain sight. In the curving lines of Art Nouveau lamps, in the embroidered borders of folk cloth, in the ceramic glaze that seems to hold a memory of rain. The mushroom has always crept from the forest floor into the artist's eye, a form both familiar and strange, the perfect metaphor for life's quiet insistence on beauty. Its domes and stems, its gills like cathedral ribs, have shaped the geometry of human imagination for centuries. Painters and illustrators chase the subtleties of its color. The faint blush beneath a white cap, the way dampness deepens pigment until it almost glows. Modern designers follow its language of curves and hollows. Architects borrow the self-supporting sweep of a cap for domes and pavilions. Fashion echoes its soft asymmetry in folds of silk. Photographers crouch low to the ground, lenses level with moss, hunting the faint halo of bioluminescent species that make night look like a starfield turned upside down. Even children, long before they know the word fungus, draw the mushroom instinctively. Red cap, white dots, small door, a home for fairies, a doorway into the hidden world beneath the grass. The image endures because it's half-truth. Mushrooms are doors' brief openings where the underground becomes visible, a punctuation mark in the sentence the earth is always writing. And some of them, it turns out, sing, not with voices, but with minute bursts of sound, too soft for our ears. Researchers using ultra-sensitive microphones have captured faint clicks as mushrooms grow tiny, mechanical sighs as fluids move, as cells expand, as pressure shifts in the gills. Within the web of mycelium, electric pulses travel rhythmically, pausing and surging like syllables. Whether these patterns are language or simply physiology is still unknown, but the rhythm feels intentional, as if the forest were tuning itself. Artists have begun translating these impulses into music. When the humidity rises, the tone deepens. When light touches the cap, new notes bloom. The result is not a melody so much as an ambient tide, the patient heartbeat of matter organizing itself. Listening to it, you sense a wisdom older than thought. The pulse is slow, exact, and endlessly forgiving. The mycelium is not performing, it's merely being. And being has its own kind of music. This hidden harmony extends even into stone. In deserts and polar plateaus where life seems impossible, fungal threads burrow into the pores of rocks, becoming part of the geology they inhabit. These endolithic fungi live at the razor edge between existence and absence. Their pigments shield them from ultraviolet radiation. Their acids nibble at minerals, freeing trace nutrients. Their metabolism slows to a whisper, waiting centuries for the brief touch of meltwater. If you cracked open one of these stones, you might find not emptiness but architecture filaments weaving through crystal, writing a biography of survival in microns. The scale is so small it becomes cosmic. To call them tough would miss the point. They are patient. They prove that life doesn't need comfort, only opportunity. Somewhere inside a sun-blasted cliff, the same processes that feed a forest are still at work, reduced to essentials. Life, as it turns out, does not end at the limits we imagine. It simply adjusts its spelling. And then there are the fungi that use other creatures as both canvas and stage. The most famous is cordyceps, the so-called zombie fungus that turns insects into vehicles for its own reproduction. A spore lands on an ant, germinates, and slips silently through the armor of its host. Inside, it spreads a network of filaments through muscle and tissue, leaving the brain just functional enough to follow new instructions. The ant climbs. It finds the underside of a leaf, bites down, and waits. From the still body emerges a slender stalk that pierces the exoskeleton and releases new spores into the forest air. It's gruesome, yes, but also exact. The fungus doesn't torment, it choreographs. It bends another life, just long enough to position itself perfectly for the wind. Scientists map the process with fascination, but poets see something else: the eerie overlap of control and surrender. Predator and gardener. The insect becomes sculpture, part of the forest's strange art collection. And beneath the horror lies function. Nutrients recycled, populations balanced. Life continuing through forms we can barely watch without shivering. Evolution, impartial and beautiful. Elsewhere, the forest's artistry turns miniature. Hidden among fallen leaves, you might find a cup no bigger than your thumbnail, cradling tiny, glossy eggs. These are bird's nest fungi. Each cup is engineered with the precision of a raindrop. When water falls at the correct angle, it hits the cup's interior just right, launching the spore packets outward. They travel on sticky cords that let them cling to twigs or fur, catching a ride to new soil. The physics is perfect impact. Splash, trajectory, a storm in the span of a thimble. It's a reminder that design does not require intention. It only requires time. Nature, left alone long enough, invents geometry more elegant than any human drawing. Then, in the shade of decaying roots, stranger forms emerge. Clusters of black clubs push from the earth like the fingers of a buried hand. These are dead man's fingers, solid, blunt, blue-gray when young, black with age. Nearby, coral fungi branch into pale antlers, intricate chandeliers made of tissue. They look like gestures frozen mid-movement, as if the forest itself were reaching up to ask a question. The illusion is so strong we forget that these shapes are simply efficient structures, optimized for releasing spores into moving air. Even the grotesque serves a function. And where there is decay, there is often sheen. Some mushrooms gleam with a varnish of slime, translucent as varnished lacquer. In bolites and waxy caps, this film traps moisture and protects against wind. In the flamboyant stinkhorns, the slime is bait, laced with sweet rot to draw flies that will carry spores elsewhere. What looks repellent to us is advertising to them. Touch one, and your fingertips come away tacky, scented faintly of sugar and corruption. The forest doesn't waste a texture. Every gloss, every scent, every glisten is a message aimed at someone, not at us, but we overhear it anyway. The palette of these messengers is astonishing. On certain mornings, when mist hangs low and the light is diffuse, the forest forgets its usual colors. Indigo milkcaps bleed blue where they're cut. Amethyst deceivers scatter violet sparks through brown leaves. Waxcaps flare in sherbet pinks and lemon yellows, as if the ground were frosting itself. These pigments are more than ornament. They shield tissues from sunlight, act as antioxidants, or lure insects with promises of nectar. Yet to human eyes, they read as pure wonder, accidental masterpieces painted on the floor of the world. Look closely, and the forest becomes a stained glass window laid flat. shafts of grey light above, a mosaic of living color below. Even in deserts, fungi keep painting. In the Atacama, one of the driest places on Earth, microscopic lichens cling to salt crystals and stone, forming patterns of green and gold. Their pigments block radiation and trap what little moisture drifts on the wind. To survive, there is to turn sunlight itself into shelter. Each speck is a declaration that life persists not defiantly, but gracefully. Everywhere they appear, fungi blur the boundary between utility and art. A slime coat that holds water becomes a glaze. A branching spore network becomes sculpture. A pigment born for protection becomes a poem of color. The line between biology and design dissolves, and what remains is pattern repeating, adapting, refining itself over millennia. The same pattern that inspires painters also instructs engineers. The same shapes that whisper myth into a child's bedtime story guide the flow of air through a city's architecture. When you stand in a forest after rain and see a blue cap glowing under moss, you're witnessing a collaboration between physics, chemistry, and time. Light refracts through moisture, pigment bends the spectrum, and the eye completes the equation by calling it beautiful. But beauty, for fungi, is never an accident. It is a strategy disguised as wonder. Think of how much of human creativity traces back to this kingdom. The dyes extracted from lichen that colored early fabrics, the fungal pigments that became the first natural paints, the architectures modeled on the strength and elasticity of mycelium. Even our metaphors, networks, webs, growth are fungal at heart. The language of connection belongs to them first. There's a kind of humility in realizing that the aesthetics we prize, balance, asymmetry, the tension between fragility and resilience, were rehearsed underground long before we appeared. Fungi invented elegance as a byproduct of survival. We only recognized it later and called it art. Maybe that's why artists keep returning to them. In an age of speed and spectacle, mushrooms insist on intimacy. They demand that you kneel, slow your breathing, and notice what's happening inches above the soil. They reward patience with revelation. The more you look, the more you see colors deepening, textures shifting with moisture, a faint pulse of life where you expected silence. There's a lesson there, not just for painters or sculptors, but for anyone trying to make something enduring. Art, like mycelium, grows by contact. It spreads quietly, linking ideas instead of roots, recycling old forms into new ones. The creative act is itself a kind of decomposition, breaking down experience into pieces small enough to feed the next imagination. And just as the mushroom rises only when conditions are right, temperature, humidity, time, creativity, too, is patient. It waits below consciousness until a moment of balance arrives, then appears all at once, astonishing and inevitable. To create, as the fungi teach, is not to impose form on chaos, but to listen for the shape that wants to emerge. The forest is full of such shapes: a black finger, a coral branch, a luminous thread, a cup that launches its children on the drumbeat of rain, a bloom of color so intense it defies naming. All of them ephemeral, all of them essential. Taken together, they form an atlas of possibility, evidence that life's first artist was the one who learned to draw with decay, to sculpt with patience, to paint with light filtered through soil. Stand quietly among them, and you begin to hear it. The faint clicking of growth, the wet percussion of droplets, the slow breathing of a world inventing itself again. What you call silence is only the tempo of another kind of music. The art of fungi is the art of persistence, beauty as strategy, sound as metabolism, color as code. And somewhere beneath your feet, in that dark network where art and biology meet, a pulse continues steady, soft, and inexhaustible. The earth, thinking, composing, and beginning once more. Long before forests thickened the continents, before flowers or even grass existed, the world belonged to the fungi. Imagine the earth 400 million years ago. No bird song, no leaves, only rock and wind and shallow seas. and on those barren plains stood strange towers, tall cylindrical forms that reached nearly 30 feet high. They weren't trees, though they looked like petrified trunks. They were fungi, vast, slow-growing organisms called prototaxites. Their bodies were built not of wood, but of interwoven threads of mycelium, the same kind that now lace through your garden soil. These giants fed on the primitive plant life around them, mosses and algae digesting what the sun had only begun to create. They were the first architects of land, taking what had fallen and turning it into soil. Around their bases, smaller organisms thrived, nourished by the nutrients fungi released. The Earth's early ecosystems were more fungal than vegetal, an immense network of decomposition and renewal that paved the way for everything green to follow. When the first forests finally grew, it was upon that groundwork, the compost of a fungal world. In the Cretaceous era, when dinosaurs thundered through the ferns, fungi were already there, weaving unseen through roots and fallen trees, ensuring the cycle of decay never stopped. Without them, the giant herbivores would have waded through their own debris. The mushrooms that sprouted in those prehistoric woods fed insects and small mammals. And when those animals died, fungi returned them to the soil again. They were the silent recyclers that made the age of giants possible. Fossils tell the story in quiet detail. Filaments preserved in ancient sediments, spores trapped in amber, delicate networks frozen in stone. Some date back over 400 million years. Others are almost a billion thin, branching traces discovered in Arctic shale, older than any plant, older even than most animal life. To hold such a fossil in your hand is to hold a signature written before time felt like ours. These remnants remind us that fungi were the first to tame stone, to draw nutrients from it, to craft the very crust that life would later walk upon. They are, in the truest sense, the planet's first engineers. Their patience shaped continents. Their appetite built the foundation of fertility. Every leaf, every root, every step we take across soil is a continuation of that original labor. The earth beneath us is not merely dirt. It is memory compacted, the residue of a billion years of fungal persistence. And out of that persistence comes geometry. Beneath the forest floor, mycelium grows outward in perfect mathematical precision, expanding in circular waves as it consumes nutrients. When the center is exhausted, the edge keeps moving, pushing new mushrooms upward in rings. To walk through a meadow and find a perfect circle of caps, a fairy ring, is to witness growth rendered as equation. The same pattern that shapes galaxies and seashells plays out quietly in grass. For centuries, people told stories about those circles, that they were left by dancing fairies, or that stepping into one might carry you into another world. Science, when it finally caught up, discovered something more profound than magic, an order that arises from necessity. The arcs and spirals of fungal colonies are efficiency embodied. They spread to maximize surface area, to touch more soil, to trade more energy. What looks like design is simply life, following the path of least resistance until the pattern becomes beautiful. Every so often, that pattern extends beyond soil into the air itself. The forest hums with traffic too small for us to see. Spores microscopic, aerodynamic, alive, rise and drift like invisible pollen. Some are smooth spheres that ride the wind for miles. Others are barbed or sticky, built to cling to fur, feather, or wing. Insects brush against them and fly off, carrying fungal futures to distant trees. A few species even sweeten the bargain, exuding drops of nectar or glowing faintly at night to attract their couriers. This is the logistics of the living world distribution, not by map, but by motion. Every fly, every breeze, every rainfall becomes part of the fungal supply chain. Even bacteria join the exchange, traveling along fungal threads like commuters on highways, using the mycelial network to move across the soil. The fungus benefits too. The bacteria share nutrients or fend off competitors. The ground beneath us is not still. It is a metropolis of trade routes, transactions, and collaborations too subtle for eyes, but perfectly tuned to the scale of a cell. This economy of movement does more than circulate spores or microbes. It holds the planet together. Mycelium binds the loose particles of Earth into structure, gluing sand and clay into a living fabric that resists erosion. In doing so, it traps the essential elements, phosphorus, nitrogen, carbon, keeping them from washing away with the rain. The soil's fertility, the lushness of forests and fields, all depend on this invisible weave. Imagine a handful of earth. Within it are miles of thread, each strand smaller than a hair, wrapping nutrients in protective loops. Those loops are the planet's pantry, its wallet of sustenance. Without them, rain would strip the ground bare, rivers would run sterile, and plants would starve in abundance. Fungi are the accountants of the biosphere, balancing the ledger of life so nothing is lost. Their work is meticulous, but also sensory. The forest doesn't just smell like earth, it smells like fungi. Lift the cap of a field mushroom, and you'll notice the fragrance of warm bread, the same aroma that fills a bakery at dawn. The molecules responsible, a family of alcohols and aldehydes, are the shared chemistry of yeast and mushroom alike. For foragers, that scent is a signal. Safe, nourishing, alive. For the fungus, it's a strategy, an invitation for animals to take notice, to carry spores to new ground. Other species compose a different symphony. The sweetness of anise, the spice of cinnamon, the faint ghost of cocoa or almond. These perfumes serve as both lure and warning, attracting the right visitors, deterring the wrong ones. To humans, they're nostalgia, a sensory bridge between the kitchen and the canopy, proof that comfort and wilderness are closer kin than we think. To the forest, they're communication messages written in volatile molecules that drift between roots and wings. Even the flesh of the mushroom participates in this cycle of generosity. It swells with rain, absorbing water until it doubles its weight, becoming a living reservoir. Long after the storm passes, that moisture seeps slowly back into the air and soil, feeding mosses, seedlings, and insects that would otherwise thirst. A single mushroom can create a microclimate, a humid pocket of air where life continues in miniature. The forest, through fungi, regulates its own weather from the ground up, and when night falls, some of those same mushrooms begin to glow. Not briefly, like a firefly, but steadily for days, sometimes weeks. The chemistry that drives their light is ancient. Luciferin meeting luciferase in the presence of oxygen. The reason remains partly mystery. Some say the glow attracts insects to spread spores. Others think it deters grazers by signaling toxicity. Whatever its purpose, the effect is unmistakable. In a dark grove, the forest floor becomes a sky turned upside down, speckled with points of greenish fire. The glow is soft, almost tender, a reminder that life continues even when the sun has gone. Travelers once called it fairy fire, imagining spirits tending lanterns beneath the trees. Today we know it as bioluminescence, but knowing does not diminish the wonder. It deepens it. The light of a mushroom is not magic instead of science. It is magic through science, a reaction precise enough to measure, yet too beautiful to explain away. To see that glow is to feel the age of the world pressing gently against the present. The same chemistry that illuminated ancient forests still burns quietly in the mulch at your feet. The same filaments that fed dinosaurs and built the first soil still weave through the roots of your garden. The same rings that spread in prehistoric meadows still shape patterns in the grass after rain. Fungi do not announce their history, they embody it. Every cap and thread is a continuation of a story 1 billion years long. A story of transformation written in light, scent, and pattern. When we look at them, we are not just observing organisms. We are reading the Earth's autobiography, chapter by chapter, told by the only author patient enough to finish it. If you listen closely, the forest will tell you this much. The ground beneath you is alive. Remembering the colors on the leaves, the fragrance of the rain, the breath in your lungs, all of it, at some point, passed through a fungal thread, and even when the night deepens and the last glow fades, that memory remains, stored in soil, waiting to rise again with the next storm. The mushrooms may fade, but their legacy doesn't. It hums beneath every step, a quiet chord binding past and present, decay and renewal. The same rhythm that once fed dinosaurs now feeds seedlings. The same light that once shimmered under ancient moons still glows in the forest after dark. Through them, the earth remembers how to breathe. Across the world and through every age, humans have turned to mushrooms when language failed them. In Mesoamerica, the Aztecs called them Teonanacatl, the flesh of the gods. Consumed in rituals that blurred the border between waking and dream, they were seen not as food, but as teachers. Shamans would eat, sing, and journey inward, guided by visions of geometry and fire, returning with messages they claimed came from the earth itself, half a planet away in the frost-bitten steppes of Siberia. The red-capped Amanita muscaria glowed against snow like embers fallen from the sky. Shamans there dried the caps above their fires and drank their essences to slip into trance. Their spirits would rise with the smoke to speak with ancestors and the souls of animals. The mushroom became a bridge, a living threshold between body and cosmos. Across Africa, Asia, and the Americas, similar stories took root of mushrooms as mediators, translators, oracles. They were seen as beings that lived between life and decay, night and day, soil and star. To consume them was to borrow their vision for a while, to see as the forest sees not as an individual, but as part of the web. Modern science, after centuries of dismissal, is beginning to rediscover what these ancient rites intuited, that within certain mushrooms lies a chemistry capable of reordering consciousness. In carefully guided settings, the same molecules once used in temples are now used in hospitals and laboratories. They dissolve anxiety, interrupt depression, ease the fear of death. The boundaries they soften are not only neural, they are emotional, spiritual. For some, the experience feels like a return to connection, to gratitude, to awe. We speak of psilocybin and serotonin, of receptors and default mode networks, but behind the technical language hums a truth as old as the fire circle. Mushrooms open doors. They do not force enlightenment. They remind us it is always there, just hidden under the noise. To step through is to realize how thin the veil between biology and divinity has always been. And yet, for all their slowness, fungi also hold the record for speed. Deep in the dung of pastures and meadows, a tiny species called Pilobolus prepares a feat of physics no larger than a grain of sugar. Its spores ripen inside transparent capsules that face the sun like miniature cannons. Pressure builds millimeter by millimeter, molecule by molecule, until, in an instant, the capsule ruptures. The spore launches at more than 20 meters per second, faster than a bullet relative to its size, rising 100 times higher than the fungus itself before drifting down to fresh grass, where grazing animals will eat it and carry it onward. What looks like stillness in the field is, in truth, full of hidden motion. These micro-explosions happen constantly, billions of times a day, filling the air with invisible fireworks. There is no sound, no flash, no applause, only the quiet certainty of continuation. Pilobolus teaches what the entire fungal kingdom seems to know instinctively, that strength can be stored in patience, that even the smallest life can find grace in perfect timing. The same balance of precision and beauty can be found in their forms. On the forest floor, coral fungi branch upward in delicate whorls, their colors ranging from bone white to flame orange. They look like reefs transplanted to land, each fork doubling surface area for spore release. Nearby, other species spread translucent umbrellas after rain, paper-thin parasols that last a single day before collapsing into the earth again. They are ephemeral, but their design is perfect. Caps wide enough to shed water, gills fine enough to catch the breeze. To a child, these shapes are symbols of magic. To a biologist, they are blueprints of efficiency. Evolution and imagination converge until the distinction dissolves. The classic mushroom-shaped cap, gill, stem is one of the most recognizable icons in human culture, drawn instinctively by every hand. It is the essence of the fungal story, simple, graceful, and transient, appearing only when conditions align, then fading back into the network below. Beneath those networks, the future is quietly being built. Mycorrhizal fungi, the same kind that nourish trees, also serve as the planet's deep carbon vaults. They absorb sugars from plant roots and lock carbon into the soil for centuries, preventing it from escaping as gas into the sky. In doing so, they regulate climate, storing more carbon than all the world's vegetation combined. The forest's conversation with the atmosphere runs through these threads. Each breath of wind owes a debt to what happens underground. Scientists are beginning to imagine how this power might be extended beyond Earth itself. On Mars or other barren worlds, fungi could perform the same alchemy they once did here, breaking down rock, binding dust into soil, preparing ground for future life. Mycelium can be grown into walls, domes, or shelters, materials that are light, strong, self-healing, and entirely biodegradable. They can recycle waste, generate food, and even block radiation. Humanity's next habitats may not be built, they may be grown. This vision of terraforming is less about conquest than collaboration. If we ever cross the stars, fungi will go with us as architects, recyclers, protectors. They were pioneers once, long before us, and they could be again. The same patience that turned stone to soil might one day turn alien dust into home. And yet, even as we dream outward, the most important work remains here. Without fungi, the living world would unravel. Forests would drown in their own fallen leaves. Plants would starve, unable to draw minerals from the ground. The carbon cycle would halt. The air would thin of oxygen. The planet's pulse would slow. Fungi are not decorations on the fabric of life. They are the fabric, the loom, and the thread together. They are the planet's circulatory system, the hidden architecture that keeps everything breathing. When a tree falls, they turn it to humus. When an animal dies, they turn it to soil. When a seed sprouts, they feed it minerals drawn from ancient stone. Every act of decay is also an act of renewal. The world does not end, it composts. Think of them as the planet's quiet custodians, the caretakers who never clock out. They work in darkness, in silence, in endless patience. Their rhythm is the heartbeat of the earth, slow, deep, and steady. To walk in a forest is to walk on their bodies. To breathe is to share their exhalation. And they are generous teachers. They show us that creation and destruction are not opposites, but partners. That beauty and usefulness can be one. That cooperation outlasts competition. Their lessons are written in chemistry and geometry, in the taste of bread, the glow of decay, the resilience of soil. Stand among them, and you feel it a hum beneath the feet, a whisper rising through roots and air. It says, we are connected. Every plant, every creature, every passing storm is part of one immense metabolism. The same mycelial logic that ties a pine to a fern also ties you to the ground you stand on. When we speak of sustainability, of healing, of balance, we are echoing what fungi have practiced for 1 billion years. They do not waste. They do not hurry. They do not isolate. They listen, they adapt, and they begin again. Perhaps that is why the sight of a mushroom still stirs something in us. Not fear or hunger alone, but recognition. Somewhere, inside our own cells, we carry the memory of that ancient partnership, written in the shared chemistry of breath. So as the story closes, imagine the forest at night. The air is damp, the soil breathing gently. Threads of mycelium pulse beneath your feet, connecting root to root, leaf to leaf, thought to thought. The mushrooms glow faintly like lanterns scattered across a vast, sleeping city. Above them, the stars mirror their pattern, as if sky and earth were reflections of the same design. If you listen, you might hear it. A low, patient heartbeat, Not yours alone, but the planet's. The rhythm of renewal, the sound of everything alive remembering its place in the cycle. And if you're listening now, let that pulse become your own. Let your mind drift along the threads that run through soil and stone, out into the dark, into the great mycelial web of being. Rest there for a while, because somewhere in that network, beneath moss and root and rain, the earth is still dreaming through fungi, through us, of everything that can still grow. Good night.